Hello guys, welcome to my YouTube channel Vishwaguru, a problem solver. Today's class we are going to discuss a numerical on the topic moment of inertia. Let's go to the numerical. An I section is made up of three rectangles as shown in figure. Find the moment of inertia of the section about the horizontal axis passing through the center of gravity of the section. Okay, so here an I section is given. It consists of three rectangles. And here we are going to calculate the moment of inertia with respect to the horizontal. That means we can say x axis passes through the center of gravity of the section, I section. So first we have to identify the center of gravity of the I section. Here, to calculate the center of gravity, as per our convenient, we will split this I section into three rectangles. Rectangle 1, 2, 3. And then this I section is symmetry about the vertical axis. So here it is not needed to calculate x bar, and to calculate this, that is moment of inertia with respect to the horizontal axis passes through the center of gravity, x bar is first of all not needed. So we have to calculate only y bar. Okay, here to calculate the center of gravity, the formulas of the rectangles that and all described in a separate video, an overview of center of gravity, and then the x bar, y bar, z bar formulas and all described in a separate video, that is center of gravity by moment method. Both the video links has been attached with the description box of this video. So go to the description box, click that video links, the reference video links, watch that video. That will be very useful for understanding this numerical. Okay, so now first I'm going to take the reference line. You know that the leftmost line is the reference line for x bar, and the bottommost line, that is the reference line for y bar. Here we are going to calculate only the value of y bar. So just to take the bottommost line as the reference line. Okay, this is the reference axis or reference line for y bar calculation. And then as per our convenient, I'm going to split the I section into three rectangles. Rectangle 1, this is the rectangle 2, this one, that is the rectangle 3. So first, I'm going to calculate the center of gravity. Okay, first I'm starting with the first rectangle, that is rectangle 1. Okay, we know that here to calculate y bar, we need a1 and y1 values. A1, that is area of the rectangle. Here you can see 60 and 20, that is B 60, D 20. So BD cube by 12. Sorry, A1, that is B into D. So 60 multiplied with 20. So we will get 1200 mm square. Then y1. Here you can see the CG of the first rectangle. That will be probably here. That is CG1. 60 by 2, 20 by 2. From this point, that will be 20 by 2. But we need the distance from the reference line, bottommost line. So this 20 plus 100, 120 plus this distance, that is 20 by 2. So 20 plus 100 plus that off distance 20 by 2. So it will be 120 plus 10, that is 130 mm. Then we have to do the same calculation for rectangle 2, the segment 2, that is the second rectangle. So for the second rectangle also, we have to calculate area and the y value. So A2 for the second rectangle, the dimension, vertical dimension 100, the linear dimension 20. So it will be 20 multiplied with the 100, that is 2000 mm square. Then y2. Here you can see the CG. If it is 100, the CG of this section, that will be here. Okay. So here, if it is 100, then there will be 100 by 2. That is 50 mm. That is from here. From here it is 50. But we need the distance from the reference axis. So this distance 20 plus 100 by 2. So 20 plus 100 divided by 2, that will be 50 plus 20, we will get 70 mm. Okay. Then for rectangle 3, the segment 3, that is rectangle 3. Okay. So here A3, the same way we are going to calculate, that is multiplication of the two dimension 100 mm multiplied with the 20. So this one will be linear dimension 100 multiplied with the 20, that is 2000 mm square. And y3, here this bottom line of the rectangle lies with the reference axis for y bar calculation. So it will be just 20 by 2, that will be 10 mm. Okay, that is 20 by 2, that means that equal to 10 mm. So now we are going to calculate y bar, which is equal a1 y1 plus a2 y2 plus a3 y3, the whole divided by a1 plus a2 plus a3. So the y bar, that equal to a1 value, substitute all the values, 1200 multiplied with y1, that is 130, plus a2, 2000 multiplied with 70, plus the third one, 2000 multiplied with 10. Okay. The whole divided by a1 plus a2 plus a3. 1200 plus 2000, that is a2, plus 2000 again for a3. Then by simplification, we will get the y bar value that equal to 60.8 mm. Okay, so now we calculated the value of y bar. Okay, so here you can see if this is 20 and this one, that is 50 from this point. Okay, so we know that the x axis, that means the center of gravity of the section, that will be less than this one. Okay, 60.8. This 20 from this 40.8 up to this, there will be 50. So here you can see it may be probably here. This is CG. Okay, that is the CG, center of gravity of the entire section. Here you can see here CG3 will be there. This one 2, this one center of gravity 3. So here this axis that passes through this center of gravity. The horizontal axis passes through the center of gravity of the section. Okay, that we can take. That means like this. Do you understand? This is the x axis passes through the center of gravity of the section. Okay. So we are going to calculate moment of inertia with respect to this axis only, which passes through the center of gravity. Okay. So here, first to calculate moment of inertia of the entire section with respect to the x axis, we go to do the same calculation for each rectangles. Okay. First, for the rectangle 1, that is moment of inertia of the rectangle 1. Okay, moment of inertia of rectangle 1 about an axis passes through its center of gravity. Okay, an axis through its center of gravity. Okay, that means like this we can say. That means if you consider this is the center of gravity of the first rectangle, then this will be the axis passes through the center of gravity of the first rectangle. Do you understand? It's CG. That means we can say this one as CG1. Okay, through CG. That is CG1. This center of gravity of the first rectangle. So that will be, we know that, guys, this for this the reference video, moment of inertia of rectangle. In that video, you can see this. So here, this will be IG. Okay, that is, we can write IG of rectangle 1, that equal to BD cube divided by 12. Here B for the first rectangle 60, D will be 20. So 60 multiplied with 20 cube divided by 12. So the IG of the first rectangle or rectangle 1, okay, that equal to 40 multiplied with 10 power 3 mm power 4. Okay. Then, but we need, with respect to x axis, passes through the center of gravity of whole section. Actually, this IG, this value is moment of inertia of the rectangle 1 about this axis. But we need about this axis. You know, these two are the parallel axis. The parallel axis theorem, that also we did in a separate video. That video link also I had given in the description box for reference, just to see this. As per the parallel axis theorem, Ix of the rectangle 1. Okay. This is moment of inertia of rectangle 1 with respect to xx axis passes through the center of gravity. Okay. So this one, that will be IG of the rectangle 1 plus A1 and H1 square. Here this H means this is the H, the distance between the two parallel axes. Okay, this is H1. Actually here, this is the reference axis for y bar calculation. This y1, that means this 130 mm. That is this distance between the reference axis and the CG1. Okay, this whole distance, that is actually y1. And the y bar, what we calculated, that is from the reference axis up to this distance. Do you understand? From the reference axis to the CG1, that is y1. Reference axis to the CG of whole section, that is y bar. Here we need this distance. So we can take y1 minus y bar. Okay, h1 is this distance, y1 minus y bar. Do you understand? h1 equal to y1 minus y bar. Okay. Generally, we can write the difference. h1 is the difference of y1 and y bar. That means y value of the particular rectangle with respect to the y bar. Because sometimes this y value of the individual rectangle will be more than y bar. Sometimes it will be less than y bar. So h value will be the difference of these two. Okay, y value of the particular rectangle or particular section, whatever, and the y bar value, okay, of the whole section. Okay, to avoid the confusion, I just erase all these lines. Okay, so I hope you all understand the difference. Y bar, that is h1, that we can take the difference of y bar and y1. Here y1 is the larger. Okay, so h1, that will be y bar, the difference y1. Now substitute the values. So moment of inertia of rectangle 1 about an axis passes through x axis. Okay, about an axis, x axis, which passes through the center of gravity. Okay, an axis x passes through the CG of whole section or CG of the whole or I section. Okay, so IXX of the rectangle 1, that equal to IG1, that we calculated 40 multiplied with 10 power 3 plus A1, we calculated the value 1200 mm square. Okay, multiplied with H1, the difference of y bar, that is 60.8, difference y1, that is 130. For this, the whole square. Even here, if you got minus, that will become square, that will be eliminated. So IXX of the rectangle 1, that finally we got 5786 multiplied with 10 power 3 mm power 4. Okay, so now we calculated moment of inertia of rectangle 1 about an axis passes through axis xx, passes through the center of gravity of the I section. Okay, same way we have to calculate for rectangle 2 and also for rectangle 3. Okay, moment of inertia of rectangle 2 about an axis passes through its center of gravity. Okay, that is CG2. Okay, that means moment of inertia with respect to an axis passes through its center of gravity. Here you can see this one CG, this is CG2. That means we can take with respect to this axis. Okay, so here you can see Between these two axes, there is some differences there. Okay. So that will be IG2 or IG of the rectangle 2. That is B dq by 12. Same formula. But here B, that will be 20. D, that will be 100. So 20 multiplied with 100 cube divided by 12. By simplification, we will get this equal to 1666.7 multiplied with 10 power 3 power 4. Okay. Then here actually this is the moment of inertia of rectangle 2 about this axis. This one passes through center of gravity of the second one. This is actually CG2. Okay, this one CG2. But we need with respect to XX axis passes through CG. For that, we have to use the parallel axis theorem. Okay. So, moment of inertia, Mi, of the rectangle 2 about XX axis, which passes through the CG of the whole section. Okay. Through the CG of I section. Okay. For that, we have to use the parallel axis theorem that I am going to mention. IXX of rectangle 2 that equal to IG2 plus A2 H2 square. Here IG2 we calculated, A2 also we know. Only the thing is H2. Guys, H2 is the distance between these two axes. This is actually H2. Okay. For that, from the reference axis to this XX axis or the CG, that will be Y bar. From the reference axis to this one, CG2, that will be Y2. Okay, from here to here is Y bar. Here to here, that is Y2. So this distance H2, that will be difference of this. So H2, that is Y bar, the difference Y2. Okay. So to avoid the confusion, I just erase these lines. Okay, whatever we did in the diagram, otherwise it will make us confused. Okay. So here H2, that will be Y bar, the difference Y2. So now substitute all the values. IXX2 that equal to IG2 that we calculated here, 1666.7 multiplied with 10 power 3 plus A2. We got the value of A2, that is 2000 multiplied with this H2, Y bar the difference Y2, Y bar 60.8, difference, it may be subtraction, Y2, that is 70, the whole square. Then by simplification, IXX2, that will be that we got moment of inertia of the rectangle 2 about XX axis passes through the center of gravity of the whole section. 1836 multiplied with the 10 power 3 mm power 4. Okay. So this also we calculated. So now we are going to calculate Ixx with respect to the third rectangle. That is, first we have to calculate moment of inertia of the rectangle 3 about an axis passes through its center of gravity. Okay, this passes through its center of gravity. That is through CG3. Okay, I just erase this axis to avoid the confusion. Now I'm going to draw the axis C which passes through the center of gravity 3, this one. Okay, with respect to this axis, the moment of inertia will be, that is Ig3. We can write that value by using same formula, that is B d cube divided by 12. For the third rectangle, B is 100, D is 20. So 100 multiplied with 20 cube divided by 12. By the simplification, we will get the Ig3 value 66.7 multiplied with 10 power 3 mm power 4. Okay. Then moment of inertia of the rectangle 3 about an axis, that is about XX axis, which passes through the CG, that is the center of gravity of I section. That means this is CG. The previous one is CG3. This one, CG3. Now this is CG. Okay. So here, these two are parallel axes. And this is the distance between the two parallel axes, that is H3. This we can calculate because, from the reference axis, this XX axis, that will be at a distance y bar. And this one, that is a distance y3. Now you can see this H3 from here to here, that is y bar. Here to here, y3. We need this distance, that is y bar the difference y3. Okay. So to avoid the confusion, I just erase all these extra lines. Okay. So now H3, that is simply the difference of y bar and y3. So now Ixx3, that equal to Ig3 plus A3 H3 square. Now substitute all the values. Ig3, we got 66.7 multiplied with 10 power 3 mm power 4 plus the value of A3, that is also 2000 multiplied with this H3 y bar value 60.8, the difference of y3, that means this one 10 mm, that also we calculated already, square for this. Okay, then by the simplification, Ixx3, that equal to 5228 multiplied with the 10 power 3 mm power 4. Okay. So now moment of inertia of the whole section, that is I section, which passes through about x axis through CG. Okay. For that, we have to add all three. That means we can write Ixx that equal to addition of Ixx1, Ixx2 plus Ixx3. Okay. So when you substitute all the values, Ixx that equal to Ixx1, we calculated the Ixx1, that is 5786 into 10 power 3 power 4 plus Ixx2 1836 into 10 power 3 plus Ixx3, that is 5228 into 10 power 3. When you add all the values, finally the Ixx that equal to 12,850 multiplied with 10 power 3 power 4. Okay, so this is the final required answer. Okay, so I hope you all understand this video. Don't forget to subscribe my YouTube channel for more videos like this. Okay, thank you guys. Thanks for watching.